Hi guys, it's Mrs. Smith here. Happy almost Friday. It's very happy since we finally get to do a lesson since we missed last week. That was so sad, but we will definitely make up for it today and maybe even tomorrow or later today. So we're starting our first unit here with distance learning, which is factoring. Um, so there's a bunch of different types of factoring that we're going to learn. But the first thing that we're going to start out with is the greatest common factor. If you look at the difference between factored form here and expanded form, what you guys have been doing recently is distributing, right? So like in this first problem, we would distribute, but this is actually factored form. So expanded form is if we were to distribute the number outside the parenthesis into the terms inside the parenthesis. Expanded form is then that answer. So we're actually going to be starting with expanded form and kind of going backwards. So we're undistributing. Okay, so expanded form is no parentheses. We use the distributive property to simplify it, which is what we've done before. And then again, factored form is like the opposite of that. So the parentheses, we have outside the number in the parentheses and then inside the number that's left over. Okay, so factoring is just to write a polynomial as a product of other polynomial expressions. And remember, product means multiplication. Okay, so like I said, there's a bunch of different types of factoring, but GCF is going to be the first thing that we're looking at. So GCF stands for the greatest common factor. Okay, so the greatest common factor is the greatest term that is a factor of one or more monomials. So for example, if we look at these two monomials here, we want to find the GCF. Okay, so if we start with our numbers, 10 and 2, our greatest common factor of 10 and 2 is 2. And then with your variables, you want to use your variable that has the lowest exponent. Okay, so p to the second and p to the third. P to the second would go into both of those. So the GCF would be 2p to the second. Okay, so same thing here for number 2. So if we look at our numbers first, we have 18 and 20. Okay, so you can always start with the smaller number. And we know that our factors are 1 and 18, 2 and 9. Okay, 9 doesn't go into 20. 3 and 6. 3 and 6 don't go into 20. So our GCF is going to be 2. And then if we look at our variables, we have a to the second and a to the first. So we're going to do the smaller exponent there, so a to the first, because it would also go into a to the second. And then this term has a b. This doesn't have anything, so b is not included in the greatest common factor because b couldn't go into 18a to the second. Okay, so we just have 2a. For number 3 here, if we look at our GCF between 5 and 4, the only thing that could go into both 5 and 4 would be 1. And then b and no b would be no b. Okay, so our GCF here is just 1. For number 4, again, we're going to look at our numbers first. Okay, and as your numbers start to get larger, if the greatest common factor doesn't, make itself clear to you, you can start always with a smaller number and kind of list the factors using that rainbow method. So 1 and 42. 42 obviously doesn't go into 56. Okay. 2 and 21. 21 also does not go into 56. And then 3 and what would that be? 14, right? Okay, 14. Does 14 go into 56? Let me look. It does 4 times. Okay, so 14 would be our greatest common factor here. All right, and then with our variables, we have m to the third, m to the third. So it's going to be m to the third. And then n and n to the second. So again, you want the smaller exponent, so it's going to be the n to the first there. All right, for number 5, now you have 3 terms. So we're still going to do the same thing. So we're going to look at all 3 terms here, and we want the largest number that can go into all 3 of those. So we can still start with our smallest number. 6 goes into itself, it goes into 18, it goes into 12. So 6, w to the second, w to the second, w to the first. So we're going to do w to the first. Okay, and then the last one here, again, we have 3 terms. So we start with our number, which is obviously going to be 7, since there's a 7 in all of those. You have t to the second, t, and t, so you want t. U to the second, u to the 7th, and u to the first. So again, the smallest one, so u to the first. And then the v's are only included in these 2 and not in the last one, so there's not going to be a v included. Okay, and this should be review with GCF. We're going to be using this, though, for factoring. So last one here, go ahead and try this one and maybe pause the video. So pause it, try it, and then you can play it again to see if you had the correct answer here. Okay, so hopefully you paused it, you did it, and then you should get 10, and it would be d to the, nope, no d, because we don't have a d in this one. Okay, f to the 8, we don't have an f in this one though, so it would just be 10 for our GCF. All right, so the way that we're going to use that when we're factoring is, again, we're kind of undoing the distributive property here. So if we look at this first example, you first want to determine the greatest common factor. So for this first one, our GCF would be 5, okay, and then it would be y. So now we're going to write the GCF first, and we're going to put a set of parentheses. And we're basically going to divide each term here by the GCF. So if I take 10y squared and divide it by 5y, that would give me 2y. Okay, oops, I guess this should be going in my next step here. Okay, I'm going to keep the same sign of minus, and then if I divide 5y by 5y, that gives me 1. So you can always check your answer here by distributing. Okay, so just like we used to do. So if I distribute this, 5y times 2y gives me 10y squared. 5y times -1 gives me minus 5y. Okay, and that is my original problem, so that I know that I did it correctly. Okay, so for number 1 here, we're going to first take out the GCF. So we know that 12 goes into both of these. And then we have g to the 4th and g to the 3rd. So g to the 3rd is the smallest. So 12 goes into 36 3 times. G to the 3rd, g to the 4th. If I divide that, I have g left over. Okay, and again, if you multiply that, that would give you 36 g to the 4th. So 12 goes into 12 once, g to the 3rd goes into g to the 3rd once. So this would be my final answer. Okay, if I divide that or multiply that back in, I get 36 g to the 4th minus 12 g to the 3rd. So same thing with number 2. I'm going to take out my GCF, which is 7, and now I'm going to do it for all 3 terms. So 42 divided by 7 gives me 6 q to the 4th plus 7 goes into 14 twice, so 2q to the 3rd minus 7 goes into 7 one time. I'm going to check my answer by just mentally distributing this back in. So 42 q to the 4th, 14 q to the 3rd, minus 7. All right, so for number 3, my GCF would be 2x, and I would have left over x to the 2nd minus 2x plus 6. Okay, I'm going to distribute this back in to get 2x to the 3rd minus 2x to the 2nd plus 12x. For number 4, when we're looking at the GCF, you always want to try to make the first term positive. So I'm actually going to take out a -9v. so that when I divide that through by that first term, I end up getting a positive v squared. And this is just going to help you later on when we're continuing to factor what's still inside the parentheses if we can. Okay, so that changes the sign here in the middle then to negative v, and then negative 9 or 1, sorry. Okay, so now again, if I check this, I get negative 9v to the third plus 9v squared plus 9v. Okay, so you always want to try to make that first term that you have left over in the parentheses a positive number. Okay, same thing here. If you see something like this, you can rearrange this into standard form. So we can put the largest value first. Okay, so we can rearrange that into standard form here. So if I'm looking for the GCF, it would be 9. And again, I want to make that first term positive. So I'm going to take out a negative 9, and then I would get 7 a to the second. And then this would become a minus 7a minus 3. So that when I check this, it's negative 63a to the second plus 63a plus 27. Okay, so for the last one here, again, if I want to make this a positive once I take out that first term, and again, if you're not sure what the GCF is, you can always start with the smaller number and start listing your factors. So 1 and 18, I know 18 doesn't go into 24, so that can't be it. 2 and 9, I know that 9 doesn't go into 24, so that can't be it. 3 and 6, I know that 6 goes into 24, 6 goes into 18, 6 goes into 36. So I'm going to take out a negative 6, so I can make this positive. And then a to the second, a to the fifth, a to the second. So a to the second, b to the seventh, b to the second, b. So I'm going to take out a b. So inside, I'm going to have left a positive 6, and then not any a's, and then b to the 6. And then it's going to be positive 3, a to the third, b, and a positive 4, and then not a to the second or b. Okay, so when I distribute this back in, negative 36, a to the second, b to the seventh, minus 18, a to the fifth, b to the second, minus 24, a to the second, b. Okay, so always check your answer here. The other thing that you want to check for is that there's not a GCF left inside your parentheses. So if you don't take out the largest common factor, sometimes there'll still be a common factor inside your parentheses, and then you could take it out at the end, even if you don't take it out in the beginning. So for example, if I only took out a 2 here, I would still see that there was a GCF of 3 in all of my terms, which I could take out and then multiply it by the 2 to get the 6 there. Okay, so this is the first type of factoring, which is greatest common factor. You're going to be using this, throughout this whole unit. So this is just the first method that we're looking at. All right, make sure that you star any questions, and then when we meet in the live Teams chat, we can go through those questions. I will talk to you guys soon.